Hello and welcome to this fabulous episode of the AI Show. How's it going? It's been a couple weeks. I want to put it out there. Where is everybody today? I want to hear where everyone's coming from, so make sure you put it in the chat. And we will say hello to everybody. Now, the last time I was with you all, I was in the throes of getting Microsoft Ignite ready, and that's over. Next week, I'm going to say this with emphasis. GitHub Universe. So make sure you tune into that. That's next week, November 9th and 10th, if I remember right. I have a session as well at GitHub Universe. I do work for GitHub now too, which is kind of cool because GitHub is fantastic. GitHub is fantastic. All right. It's time to pull our pandemic purchase out and tell you what's going on today. Let's see. Screen number 3. Sharing screen number 3 right now. Boom. Today we've got a lovely episode for you. Let me get my pen out here. We're going to be doing a ton of cool stuff. We have not one, but two fabulous episodes to talk about. Number one, we are going to work with our good friend Manoj, who is an awesome dude, and we're going to talk about Azure ML Registries, which is, to me, super exciting for a number of reasons, which he will talk about. So he is here. We recorded the thing yesterday, and then we're going to play it like our custom is. And then Manoj is going to answer every complicated question up to and including the meaning of life. Manoj knows. He knows. Manoj knows. Number 2, we are going to be looking at, oh man, it just went in my head. Multivariate anomaly detection. Yeah. It's great. She's in China, though, so we also record that in advance. I think she's in China. Yes. And so I did not want to ruin her Friday evening. Or Saturday morning, in this case. Or middle of the night. I don't know which kind. I don't know. I don't even know what time it is. And I feel like I want to look up what time it is. Well, let's see. What time is it in China? 2:04 a.m. 2:04 a.m. And I just wasn't about to keep her up at 2:04 a.m. in the morning. And then number 3, or whatever time, we'll do this at the top of the next hour. This one we're going to do soon, during this hour. So get your questions ready. And number 3, we're going to keep working on Rochambeau. I think I've made some changes. Changes. So I'll read you in on those changes, and then we'll work on it some more because we got to ideate. That's such a terrible word. Ideate. It's like I'm some kind of robot.
Hello. Today we are going to ideate.
You know, it just sounds terrible. All right, where is everybody from? Let's see here. We have Patty. Oh, I know Patty. Hi, Patty. We've emailed from Lexmark. Look who's here. Kevin. From the beautiful Midwest. Is it cold there yet? So I took my kid to the bus stop today because it was my turn, and I was wearing shorts and sandals. Clearly not. Clearly not weather appropriate. So I told them I was in denial about it becoming winter. Denial. I should have said I was in Egypt. A denial. Uh? Uh? These are the jokes, people. Okay. DF Meta. Bienvenido, amigo. And then we have Richmond, to be precise, in the Commonwealth of Virginia. Welcome, welcome, my friend. It's so good to have all you all. This is designed to be interactive, except for the parts that aren't. So feel free to have some questions and interact. I'm going to be doing some code in between some of these fantastic episodes. But without further ado, let's see if my good friend Manoj is here, or he saw that intro and was like, I'm out of here. He's here. Manoj, how you doing, bud?
Great, Seth.
We work together. People don't know this, Manoj, but I have not been in developer relations for over a year, and I work on the same team as you, kind of, right, Manoj?
That's true. We love
Just
your demos and sessions, Seth.
he's so nice. He as soon as he said it, he was like, "That's true. We have to put up with him." It's very
But I
scary.
thought you're also working with GitHub now.
I am. I am also working with GitHub now, so it's like I have a couple of jobs, which is great. So I love GitHub, by the way. One of my favorite tools that I use all the time. I'm sure it's yours too, Manoj. Is
Yep,
it your
yep.
favorite? No, your favorite tool is Azure ML, man. It's your baby. All right.
Yeah,
So we recorded a thing. So this is what we're gonna do. We're gonna play it. And then you okay sticking around answering any questions, Manoj?
absolutely.
Mm. So let's do that. I'll play that right now. It is a delightful little jaunt into the world of, and I'm gonna do emphasis on this. Azure ML Registries. That's how good it's gonna be, Manoj. So let's play it right now. Here we go. AI show where we talk all about the latest from Azure ML Registries, enabling better collaboration and ML ops with my good friend Manoj. Make sure you tune in. Hold on, are we getting a little squirrely? Are you getting a little are you seeing it, or is there like a loading thing? Are you
There's a loading thing, I guess.
Oh, loading thing, that's garbage. I'm gonna redo this because you know what? We got to do better than that. So let's add it right now. Again, I put this into storage. Are you ready? Here we go. Here we go. You're not going to want to miss this episode of the AI Show where we talk all about the latest from Azure ML Registries, enabling better collaboration and ML ops with my good friend Manoj. Make sure you tune in. Hello and welcome to this episode of the AI Show where we're talking all about the latest from Azure ML Registries, enabling better collaboration and ML ops. Manoj, how you doing, my friend?
Doing great. Nice to be here, Seth.
Fantastic. Now, if you don't know, Manoj and I work together all the time. But why don't you introduce yourself for people that don't know you?
Yep. I'm a product manager on the Azure Machine Learning team here at Microsoft, working on ML ops and collaboration areas. Here to talk today about this new feature that we are doing, Azure ML Registries. Super excited about that.
Fantastic. So, for those that don't know what registries are, can you help us set a little bit of context with this?
Yeah, you all know about this iterative way of developing machine learning models. But in the real world, we really think of scaling this when we look at large enterprises doing machine learning. You kind of go through different stages. Like, you kind of have a prototyping phase where one data scientist is working in their local machine with like maybe notebooks on an idea. and then you kind of really scale it and try to run it in the cloud, do experimentation tracking when you get to the training cycle. And then that's where you also kind of loop in more stakeholders from your team to review and participate in model development. And that's where you kind of standardize all your experimentation. And finally, once you kind of have a good base model that you want to then roll out and integrate with your application, is when you get to operationalizing your model. And this really involves integration with the application stack and deploying the models, A B testing, rollout, and managing all that stuff that happens in complex IT environments.
I mean, this is a
Uh,
really cool way. If I may, this is a really cool way of looking at it, because the one before was like you prepare your data, then you make it, but nobody actually does this. It's more of an iterative process from prototyping all the way to operationalizing. Is this what you're trying to get at a little bit?
Yes, and to introduce registries, you really need to understand like what are the pain points, to make this successful, right? So that's where we like get into a little bit under the covers and like say, hey, this all looks good, but how do I really do this in my maybe Azure environment, where I have this maze of different teams and different resources, different subscriptions, different workspaces, whatnot. And then like I have to manage complexity around like, hey, I need to deploy this model to 7 regions because you need low latency access and a lot of that kind of stuff. So really, when you think of this kind of a setup, inevitably you are working across teams, you are working across different Azure subscriptions and what we call as a Azure ML workspace. And that's where the complexity comes in today. You can't really move assets like maybe your models and pipelines that you maybe developed in a workspace that you were using while prototyping. There's no easy way to move it, like let's say into a production subscription that's hosting your models. And that's what we plan to solve with registries here.
I see. So if I'm understanding right, and this is now starting to make a lot more sense, you're saying that each of the phases of machine learning, when you're prototyping, training, operationalizing, those things sometimes happen in the various different subscriptions and workspaces, and there's really no way to solve the problem of having shared assets without this registries thing that you're talking about.
Exactly, and that's where like things are like lineage come into picture. Like imagine there's a production endpoint, model deployed to a production endpoint, and there's like a performance is not great or the model is behaving erratic. Then how do you kind of get back to the job that trained the model, the data that went into training the model? Where is the code that was used to train the model? So all of these questions, if you are doing them in different environments and you're like lifting, shifting, moving these assets manually, you kind of lose track and end up in a maze.
This is cool.
Yeah, so Azure ML Registries, these are central catalogs for machine learning assets, and they can like facilitate sharing of machine learning assets across your entire organization. So, just illustrating the concept here, we kind of want to switch over to the UI and look at this stuff in real.
Yeah, this is cool. I'd love to see this in action if you can. Can you show us an actual workspace that has well, I don't know. Like I'm trying to distinguish between a workspace and a registry. Can you share a little bit about how those things work together?
Right, right. So, when you come to Azure ML Studio, you land here. This is your global homepage. Uh, till today you typically pick up a workspace and go work in that workspace. You have your models, you have your jobs, and all the cool stuff that you kind of work on a project related to machine learning. You have it all here. But then let's look at this is my dev workspace. It's in probably my dev subscription. But what if my IT environment requires me to deploy this model in a different subscription with different kind of compliance and security requirements? That's where like registries comes in. Registries are these central machine learning catalogs that can hold different kinds of these ML assets like your models, your pipelines, and all that stuff. And then they can kind of deploy to all the different workspaces within your organization. So this is like the Contoso ML registry you're looking at. And let's go and look at like what's in models here. So you have a machine learning model. And note that how we transitioned here into the models hub. So imagine like you are a data scientist, you come here to Azure ML Studio, and you just want to look at like all the shared models within your organization. You just land here, and then boom, you kind of get a view of all models that are shared in your
That's cool.
organization across various registries.
Yeah, and the thing about that I'm liking is that because you may have multiple teams in a large enterprise producing assets of various stages, for example, you can share those out to everyone else in your organization with this feature. Is this right?
Yes, exactly. So not just multi-environment ML ops, but this can also kind of light up as your central organization catalog for ML models and pipelines.
That's cool. So you might have people, for example, specializing in ML engineering that make the company pipelines that then you can put your models into, for example.
Yep.
That's cool.
So you have like these system registries where Microsoft is going to bring you a bunch of cool assets, and then like these are your organizational registries where you kind of manage them for your organization.
That's what. Can you show us what you can do with models? Because I think that's the fundamental like artifact of machine learning. Can you show us what you can do with these models from the registry?
Right. So before we go into like the model, let's look at how the model got here in the first place. And to
Oh,
do that, maybe like we'll try to train a quick model.
yeah, I think that's great. I totally jumped ahead because I'm excited about the sharing part. But I guess a good question is how did the model get here in the first place? So can we dive into that a little bit?
Yeah. And to do that, like let's go over a little bit to some machine learning code here written in Python using the Azure ML recently released Azure ML Python SDK v2, uh, and basically just walking through a couple of cells. You kind of have these clients that you kind of use to interact with either the workspace or your registry. So I'm initializing a few clients here, one for my dev workspace, one for my prod workspace, and another client for my registry. And then basically, to run a training job, I need an environment. A machine learning environment is like this Docker container that kind of has all this stuff. So in this step here, I'm defining a Docker environment, and I'm creating this Docker environment in the registry. So look at this command. It says like ML client registry environments get, that's fetching the environment that we created from the registry. If you were to just swap this command and like use ML client for your workspace, you would get environments from your workspace. So using a registry or a workspace are near identical. It's just like what clients you work with, and it's the same asset. You can like put it either in a workspace where you use it within that project or the team, or you can put it in the registry and use it across multiple projects and teams.
I see. So
Uh,
that enables a situation where you might have some assets that you're working with in a registry that's saved in your workspace, but isn't yet available in a public or a tenant level registry, and you can sort of move things in and out. Is that right?
yes, and we are going to actually do that when we get to the models part as
Oh,
well.
okay. Jumping ahead here.
Yeah. So I got my environment, and I do the same thing with a component that trains the model. So the component is now published to the registry. And before we run the training job, I just want to hop back once quickly here to our registries and like just recap what we looked at here. We looked at basically the training environment that we are going to use, and the training component that you are going to run to train this model. So here is next, like basically the simple pipeline job that uses the training component to run to submit a training job. And note that like the training job, like the jobs essentially need compute and all of this stuff, and registries are only for hosting assets. And that's where like when you run this job, you are actually submitting this job to the workspace. And this is different from like the environments and components that you saw, that they were created in the registry and they used the registry client. Whereas the job that I'm going to submit to train this model, I am submitting it to the workspace, and this job pulls the environment and the component from the registry, to run the job in the workspace and produce the trained model. So now that that job is run, let's head over to the studio to go look at the training job. And now you see I'm back into my Contoso ML dev workspace. This is the training job that ran. And if I open up this training job, uh, it will show me that it used an environment. And this environment came from the registry. So it's not there in this workspace. It pulled an environment from outside this workspace, ran that. And this was the component that was used to train this model. This component also came from our Contoso ML registry. And then it ran some training code and produced this ML flow model. Uh, and I'm now going to like register that model into this workspace, and let's look at how that feels like.
Hold on, go
And
back. That was really fast. When you hit like register model, is that new? I haven't seen that before.
yeah, so you can like work with job outputs, and those job outputs are either like data outputs or they are like model outputs. And if they are models, you can like choose to look at them and then register them in
That's
your
cool.
workspace or in the registry. Yep.
Let's go. Yeah, that's cool.
So NYC
And
demo.
as you're typing this in, it basically recognized that it was an ML flow model and pulled all the right files.
Yes, exactly. And it kind of detected all of that stuff. It detected the model type.
That's cool.
Yeah, let's give it like version 2 maybe, and then click next and register. And now I have my model created in this workspace. So I can come here and look at this model. Now this model is currently only within this workspace, which means I can deploy it only inside my Contoso ML dev. But what if I kind of need to really deploy this into like maybe a different workspace? Like I have my workspaces here, and I have my prod workspace as well. Like this is the Contoso prod workspace. So let's look at like how can I put this model into the registry so that I can deploy it to my prod workspace. So I say share model, and I pick the name of the registry where I want to put this in, the Contoso ML registry. I can either keep the name same or like change it. That's completely optional. And I say add. And this kind of gesture now triggers a activity that puts the model into the Contoso ML registry. So let's head over there now and go to models. Uh, this operation is going to take a couple of minutes to run because it has to fetch all of that from the context of the workspace and bring it to the registry. So for our demo today, like I already had a model that was put into the registry, and this was actually done by the training notebook that we were following along
Right.
here. And if you look at the subsequent cells, it has the code to do this stuff as well. And from this place, I can actually say deploy model. And when I say deploy, again, just like a job that runs within a workspace, even the models that are deployed require compute, and they need an endpoint, and all of this is inside the workspace. So I kind of pick what workspace I want to deploy this model to, and I say proceed to the workspace for deployment. And now you saw that I'm actually in the prod workspace. So this model was trained in the dev workspace, staged into the registry, and now it is uh, inside my prod workspace ready for deployment. So the model is detected. We came in from the model, and then let's do some default settings there. We don't need an environment because ML flow, we understand what the model is. We'll figure out the environment for you. The compute stuff, maybe I just need one count here. Uh, Traffic 100%, next, and finally create. And this kind of this you saw that now the model is getting deployed to my prod workspace here. And this operation might as well take a minute or two. So maybe let's go switch over to again to the prod workspace and look at another endpoint that I had just deployed for this demo. So this is the endpoint that I initiated for deployment, and this is the endpoint that I had deployed just before our demo so that we could get to this quickly.
If we could
And
pause for a second here, because now I'm starting to realize, and maybe here, let me show our faces here. So now I'm starting to realize, how does it maintain? Does it maintain the lineage of where it got the model from? Because now I'm understanding that the model was trained here, put into the registry, and now it's being put into production. Can you trace it all the way back?
Absolutely, and that's a great point that you bring up. Like, if you can't really trace back all the lineage, then like this feature is probably incomplete, right? So yeah, and so this is the endpoint. I can like do some sample testing with this endpoint here, but more importantly, this is the deployment. And if I closely look at this deployment, it tells me what model is deployed to this endpoint. And remember, we are here in the prod workspace,
Right.
and this is the model. And I can click on this model, and I'll now go back to the model in the registry, right? Like, we came back from the prod workspace into the central registry, and look at this thing here. It tells us like which job had trained this model to begin with. And I can like navigate to the training job from this model, and now I'm taken into the dev workspace because this model was actually trained in my dev workspace. And and at this point I can review everything here. What was the environment that was used to train the model, so what packages and all of that stuff that was used. Where did the training code come from? It came from this Git repository. This was the actual Git commit. You can actually navigate to that code in Git directly by clicking here, but we'll probably skip that for now.
That's
And
cool.
we also tell you like what was the data on which it was trained on. So I can like click on this link and go look at the training data as well. So this was the training data. I can go do some quick exploration on what data it was trained on, and I can look at all of that stuff. uh, and basically this ran as a pipeline, so I can come back and look at maybe other steps of this pipeline. If I had a data processing step and evaluation step, all of this is visible as well. So just to recap, right, like we started with a prod endpoint in the prod workspace and navigated back to the registry and then to the dev workspace and all the other things that were associated with my model training.
Yeah, that was really cool, and I'm glad you kind of dove us well navigated around so we could see it, because you actually showed how using the registry as an intermediary allowed you to move assets between workspaces in a really seamless way without losing lineage, which I thought was awesome.
You're right. And now you can probably relate to this slide here when we say that, like, inevitably you are going to have different workspaces, different subscriptions, different projects, and all of this stuff. And if you kind of leverage the power of registries, you can cut across all this complexity and have a central catalog for all your machine learning content in the organization.
I'm a huge fan, and like I was telling you before, one of my favorite features in Azure machine learning that goes to the promise of collaboration at an enterprise scale. Where can people go to find out more?
Yeah, so we have a blog post on this topic. You can start there, and then that blog post has more links, to the tutorials and stuff like that. And we have like these sample notebooks as well. So yeah, we'll probably link all of those in the video description.
Absolutely, and I'm putting them up here for y'all to see. Here's the documentation link. One more time, here's the tutorial link, which is awesome, and then here is the blog post. Well, my friend, thank you so much for spending some time with us.
Great, Seth. Thanks for having me.
All right, my friends, we've been learning all about the latest from Azure ML Registries, enabling better collaboration and ML ops. Thank you so much for watching, and hopefully, we'll see you next time. Take care. How about them apples? Sorry, my volume was down. Wasn't that cool? I thought it was cool. Manoj. Anything as you were watching Manoj, is there any extra things that you're like, oh, I should have talked a little bit more about this or that? Any additions to what you already said?
Um, Probably not, but I see there are a bunch of interesting questions in the
Yes.
chat.
Yes, we have Kevin, who has always has good questions. The one that I like, here's one. Here's one. What options? Let's see. What options do we have for approval or conditional gating when importing a model to the registry? By the way, but keep your questions coming. Manoj has been so gracious to say a little extra and answer these questions. So, options for conditional gating of importing assets into the registry, which is even more general question. Thoughts?
Yeah, I'll answer that question in two parts: what you can do today and what we'll plan, to support in the product in future. What you can do today, registries are top level ARM resources in Azure, which means you can leverage Azure RBAC, or the permissions capabilities, to say like, hey, all my data scientists in the organization have access to read and use models from this registry, but I just have like these five people who can like really approve or create assets in registry. And when I say create, you are directly creating them in the registry, or you are importing them from a workspace into the registry.
Got
uh,
it.
so have a narrower set of people who have the permissions to do this kind of approval stuff in your organization, to promote models from the workspace into the registry. So that is like what you can do today. In future, we will have capabilities where somebody who doesn't have permissions and still wants to share a model, no, they will request a shared model, and instead of like saying no, you don't have permissions, we are going to send a notification to all the users who have access to actually promote that model, and then they can like actually complete that activity after like putting in whatever justification is needed there. We are also working on notion of stages and approvals for all the assets in the product. So you can actually tag product assets as they are in dev, test, prod, canary, those things, and we'll integrate with Azure policies. So not just the approver, like the Azure system itself is going to prevent you from deploying a model into production if it doesn't have these tags, or it is not following the set of policies defined ahead of time, using the policy mechanism in Azure.
Interesting. So I heard a couple of things. The first thing is that a registry is a top level Azure asset. That means you can do all the Azure things with it. Did I get that right?
Yes, you can
And
use ARM
yeah,
templates for no, provisioning and automation. You can use all the permissions management that comes, for all Azure resources, the RBAC stuff. Define your own roles, define your user groups, all of that.
that is delightful. And the second thing I heard is because of that, you can do RBAC controls over what's put into registries today. But moving forward, we're going to add some features to do even more wonderful stuff, basically.
Yep.
That's delightful. Another question from Kevin here. And this is a good one as well. If you delete the workspace that a model was generated from, does the lineage stay with the models in the registry or is it lost? This is a good question.
Yeah, uh, and I wish I had a better answer for this one. The model stays, you trained the model in a workspace and then promoted it from the workspace to the registry, and you deployed this model from the registry into a production endpoint, and now you delete the workspace in which it was trained. Fortunately, your model stays. Your model is not lost because it is copied into the registry. What happens to all the training metadata, the training experimentation metrics logs that were there in the workspace? Yes, they are unfortunately deleted, and you would probably have a dead link uh, to that. When you say like, take me to the job that trained this model, you would probably end up with a dead link. That kind of gives me good feedback that our users care about this stuff, and we want to like selectively import some important metrics about that model training along with the model into the registry. We'll go back and explore those things.
Yeah, and it's I'm trying to think of the analogy because I always look at machine learning as just programming, but with data as well. Yeah, I mean you have code and you have a model and you shove data through it. I think what Kevin's asking is what happens if you put your package in npm, for example, but delete your repo.
Yeah, good analogy.
It's a similar analogy. Well, you're gonna lose some stuff. And the question though that I like how you're posing this, Manoj, is maybe there's some things that we should put in a registry because model building is different and we need to explore that a little bit as well. Is that kind of what you're saying?
Yep. And we have got other scenarios on similar lines. Like, let's say the workspace in which you trained this model, users don't have access to that workspace. Now these are org registries. Everyone in the organization might have access to that registry. And what if they want to look at some sample jobs on of, the model, how this model was trained? So we are exploring those things of how to associate some metadata around training with a model that's imported into a registry.
And that's another interesting question, because I think it goes to what Kevin was saying is, what if you have two workspaces, and in one workspace you're generating models with sensitive data that not everyone can look at, but those models are available to everyone in the tenant? Those links are also going to be semi-dead links, in the sense that you can't go there and look at that stuff because that's the company policy. Is that right?
Yeah.
Well, that's cool. That's cool. And then I think Kevin made another comment about, along the same lines, if you attempt to delete a workspace, should be alert folks. That's a good suggestion. Absolutely. All right, let's see what else we got here. There's another question. Oh, great question. Here's a question from Mark Whiting. Nice tooling. Is this available to enterprises only?
Um, I think I would, Seth, you can probably chime in here, but Azure ML is open to all customers, and by definition, like there is no extra premium that we charge for registries. If you have a Azure subscription, you can go create a Azure workspace today. You can create a Azure ML registry today. And there is nothing that prevents you, that's limited only for enterprises, but you need an Azure subscription.
Yeah. So basically, if you have an Azure account, you can go make this today.
Yeah.
Now, is the thing, here's a question about registries that maybe people don't know. Are registries like in preview right now? Is this something that's out? Is it something that people can use confidently today?
um, they are out, people can use it today. They are in the state we call public preview, which means there might be some rough edges, but we are looking for users to try them out and like give us feedback about what's working, what's not, so that we can fix them, polish all of this stuff and get it to what you call general availability in the next few months.
That's fantastic. But Manoj never puts out stuff with rough edges. Trust me. All right. Let's see if there's any. Okay. Here's a very important question, Manoj, and maybe you can help. No rules, only tools. They are in need of a girlfriend. Anything that Azure ML can help with there?
Train a model to find good potential targets.
That is the most engineering answer I have ever heard. It's time for you, my friend, to go build your own OK Cupid with your own custom models generated by Azure Machine Learning. Go forth. Is that what you? Oh my gosh, greatest answer ever. By the way, Janiscu number 7, welcome. Hello, my friend. Welcome, Janiscu number 7. I rushed it. I'm so sorry. Yeah, that diagram that you had of the machine learning life cycle uh, is awesome. I have been actually showing that to all of our customers, and they're like, "Yeah, that's actually more of what it's like." You want any commentary on that life cycle of machine learning process?
Yeah, I think when we typically showed the model building activity where you are like build, not explore data, train a model, deploy a model, and then retrain. That was like just one person, right? Like I'm running the show. But how do like enterprises run the show? How do large teams, multiple data scientists run the show? And that is what we kind of feel would be prototype, train, and then operationalize models.
And it's not like a nice phase of like, we are done exploring, time for training. It's more of like a messy, we're in a loop, we pop out to another, we pop back, and then we go over, and then stuff happens all over the place. And this is what we're finding at large enterprises that I've been talking to, and you too, Manoj, that this is what they're actually doing. So if you
Yeah.
are like, well, our machine learning practice feels a little messy, that's the way it's supposed to be. Comments, Manoj?
Yeah, a bit messy, but we are building the tools to make it a bit less messier.
We are your machine learning janitors. That's what we are. I mean, would you say that that is the case? It's like the worst. The worst. Hey, here, I'll do a little commercial. We'll do it together. Azure ML, your machine learning janitors today and tomorrow. That was a great commercial. We should record this. Wait, we are. All right. Any
Seth,
final words, Manoj?
you should be producing movies.
Yeah, that two people will watch. One of them's my mom, and then the other one would be you. Manoj, any final words about Azure ML Registries before we say goodbye?
No, I would say like just try this out. Reach out to me. Comment on the blog post or ping me on LinkedIn. And I'd love to hear what you folks think and share feedback.
Yeah, go try this stuff out. If you're just a burgeoning machine learning practice, having your own internal registries with assets puts you far above the majority of companies that are doing machine learning. Would you say that's the case, Manoj?
Yep,
Yeah.
100%.
Yeah, absolutely. All right. Well, thank you so much. We'll give a round of applause to here, Manoj. Thank you, sir. And we will see you at work, my friend.
Yeah. So Seth is saying like get back to work, Manoj. Now the nice part is done.
No, man, you're carrying the company, bro. So let's get
Oh,
back to
wow.
work. All right, we'll see you, buddy.
Okay, bye bye.
Bye. All right, that's Manoj. He's such a good dude. I enjoy working with him. Absolutely, great questions. I honestly think that the registries feature is probably one of the best things because now we're able to separate assets, machine learning assets from the production of machine learning assets, which is similar to what we're doing in regular software. If you think about it, you build your JavaScript thing, and then every day someone puts out something in npm, and those where the assets live, and then where the thing where the production of that asset lives. Yeah. And to go with Janiscu number 7, asset off, asset on. Yes. I haven't finished the latest season of Cobra Kai, by the way. No spoilers. Okay, no spoilers. Great questions, Kevin. Yeah, that's right, Manoj. Thank you for that. Great questions. Okay, so what I'm going to do now is we're going to wait till the top of the hour to look at some of the stuff that we did. Hold on, let's see. I want to make sure I remember this right. Louise Han, who is awesome, she's going to talk a little bit about multivariate anomaly detection. And the cool thing about multivariate anomaly detection is when you're at dinner parties and you're like, hey, what do you work on? And you're like, well, I work on multivariate anomaly detection. Yeah, it will draw ooze from the crowd. Multivariate anomaly detection. Yeah, I thank you. I mean, it's just, can you explain that to us, Seth? Well, I have to go. Sorry. Louise Han will explain that to us at the top of the hour. She's fantastic, and she's in China, and so I did not want her to get up at 2 a.m. to be on this show. Although it probably would have made it better if I'm being honest. All right, so let's go back to some of the work that we've done here. Here is my screen. I haven't opened. I don't even know what project I have open right now. Psst. What project do I have open? Oh my posh. Ooh. What is going on here? Oh, something is broken. Ooh. Oh. There you go. Now it looks better. Let me see if I can start that again. Because I'm trying to remember what I was even doing recently. Okay. So look like this is called Tlaloc, which is the Aztec god of rain. Oh, I remember what this is. We were doing time series analysis to predict prices, prices of how much earnings we were going to do, and I named it Tlaloc after the ancient Aztec god of rain because these earnings report were going to make it rain. Make it rain. The ancient god of Aztec god of making it. So that's what I was working on. And so that's why this is the thing that opened. So let's open our recent Rochambeau to remind ourselves where we left off, and then we'll write some code. And I'll tell Siri to wake me up in 15 minutes. Timer for 15 minutes, Siri.
15 minutes, counting down.
Thank you, sir. My digital butler is going to remind me in 15 minutes that Louise is going to talk about multivariate anomaly detection. I still like the guy that asked about a girlfriend, and Manoj was like, you should build a machine learning model to figure that out. Hey, stranger things have happened. So that was really cool. All right, so let's go back and let me remind people what this does, and we'll go from there, and then see what I've even done. So cd web here, yarn dev, and I think we've decided, if I remember right, that the hardest part of this entire machine learning project was learning React. I think that's what we decided. Let's control click this thing here. What do we got? Here we go. Rochambeau.ai. Let's choose webcam C920. And then when I do this, it should say something like rock kapow. Oh, man. Our machine learning model is not good. Hold on. Maybe if I go like this. Paper! And then nothing. Yes. Yeah, I mean, if there's anything that this face tells you, it's definitely none. Sorry, none. So, and it's pretty good. It's like 62%. Although they are telling me that I look like a scissor face. Scissor face. There's a movie about that. Someone pointed out when they saw this demo that they saw my tagline, "You will have the greatest fun of your life, entire life, for sure." And websites don't lie. So there is that. So this is what we built. The front end part. Yeah. Let's. React was the hardest part for Seth. Not the multivariable vector calculus machine learning model that we trained like 800 times. That wasn't the hard part. It wasn't the back propagation that was doing calculus in like, I don't know, a couple thousand dimensions. It was literally React. And if we want to be clear, this was the React that I had when I had to do React. This. Okay, now it looks like I'm eating an arrow, and this is weird. So let's stop that. And incidentally, by the way this is working is I hit this in the wrong one. Sorry. We'll go back to here. Control Shift I. The way this works is it actually sends a request. We'll do another one. Is it sends a request. Like, I feel like I'm judging myself. Like, imagine you woke up to this. That should be a t-shirt. But it sends a request to Azure Machine Learning. Let's see if we can find this endpoint. Come on, wake up, Azure ML. Wake up. It's thinking. One thing that I do is, and that I need to be careful about, is I am actually working off of our main branch. So sometimes features leak. And the cool thing is that you can actually now on Azure Machine Learning is that you can actually turn off and on preview features. So the latest one that's disabled is see the operating system version your compute instance is running on to understand whether you're up to date with the latest software. I'm going to turn that on. Tell me what is going on. And there's a recent change in our facade. Look at that. And there's even videos that they, look at this. Look at this goodness. So what you're seeing right now, might appear a little bit in that one. Like the one we just did with Manoj, for sure, will probably be in here. And if we want to make some more, if you want me to make some more, just tell me what kind of videos you want to make. Okay. So let's go to the endpoint because I was showing you what it's actually calling. It's calling this Rochambeau app thing. And if you see the test, it's sending like the image, but the way that it's sending the image is it's sending it, if I remember right. Let's see how it's sending it. I think it's sending a base 64 image version of it, if I remember right. So here's the, yeah, so it gets the frame. Let's go to that definition. There's the get frame, and then that here it is. Yeah, so that get frame actually makes the picture smaller, draws the picture into a canvas element, HTML canvas element, and then it returns the data URL, which is a base 64 image. So that's what's happening. If you look at the AI bit where it does the inference is right here in the score, and you can see that when the scoring comes in, it checks to see if it's a base 64 image. Do you see that? That's why that thing is happening. Then I decode the base 64 image in the first thing because I split the comma because we don't need this thing. And I get the second one. I use Pillow to open the image, and then we do the standard PyTorch transforms, and then we run the Onyx runtime session. And that's what gives us the prediction. So this is happening in Azure Machine Learning. Any questions about this? It's awkward because anytime I say any questions about that, I got to wait 30 seconds for someone to ask a question because, yeah. Except for on Twitch, because Twitch is immediate. Because JanXQ number 7 already said Onyx is good. Yeah, it is. It is good. Thank you, sir. Okay. So that's what we're doing now. One of the things that I've recently changed, yeah, Onyx runtime is also good. Thank you, kind sir. One of the things that I recently changed is this cloud thing, right? So let me undo whatever change. What changes did I do? What did I change? Let me discard changes here. Oh wait. Oh, we don't want to do that. There you go. So I made some changes recently to make this all a little bit more Azure ML v2 happy. And so if you go to this, you're going to see in the cloud area, I describe the training job, and it just runs the Python thing. Here is the data set. I just pointed it to my data store. Remember, we were getting errors about that. And then my environments now are more classic environments in the sense that they're literally Docker files that I know work. I could probably slim this container down some, but that kind of work is awful in the sense that you try something and then it breaks, and then you do that 8,000 times over a period of many hours, and I don't want to do that. And then for deployment, you can see the deployment is here. One of the cool things that's new in the V2 is that you can actually use tags to look at the version of the asset that you're going to use. And our PyTorch Lightning GPU deploy has many versions, and now I don't care what they are. I literally just have to say latest, and then the endpoint is just this simple thing. So then the thing that changed is this. Now when I do the CI/CD, I made a change to when I create the model. So that looks okay. So here's the score. No, so this is the deployment. Here it is. This is what I've done now. Because before I was really frustrated by this. I could not get, lineage, which is something that I'm still judging myself a little bit. I'm going to leave that on for posterity. One of the things that I did not like is that I was unable to get lineage. So for the one that's running 3347 here, now notice that now I'm able to go to the actual model And because I registered the model using the CLI with that new thing, now I can get lineage all the way back to the job. And this is the job that we ran. You can see the standard log here, which is super nice. And it can point people back to the actual data. So as we explore the data that we use to train this model, I'm gonna sit up. It's like I got like a dismembered head in there. You can see that it's again this guy. But do you see how unhappy I am? It's because I didn't have this. Right now, this is past Seth saying, "Where is my GitHub thing?" And so that's what this little thing is doing. Now, when I say AZML model create, let me zoom it a little bit. Actually, let me just go full screen so you can see it real good. Now, when I say AZ model create Rochambeau model and give it the version, I can also give it the path to load the artifacts from. So here is the artifacts. It's jobs. This is the actual job name that I gave it. Here's the output artifacts, and then there's the where the model is. And so if we go back to this whoa, who's this guy? If we go back to this thing right here, oh man, I might need to go back all the way to the, come on. Model number 9, job number this. If you go to the outputs, you'll see that there is this output things where the actual model and metadata live. And that's now what I'm pointing to using this style of command. I'm telling it the path. So instead of uploading artifacts, if you looked at the old version, I downloaded the artifacts and then re-uploaded them. Here, I'm just providing a pointer to a job's output in the model. And that's why the lineage is still there. Hopefully that makes sense. And that I think was probably one of the cooler parts of the new stuff that I've just added. Okay. Yes. Yep. That's it. Okay. So now we need to figure out what we're going to do moving forward, because I think I've got something that works. The problem that I have and that I don't like, again, between us ladies here, if I go to github.com Rochambeau, you are going to see oh man, it's going to make me log in, isn't it? My internet is so slow today. This is so bad. Awful. GitHub. My main branch isn't protected. So if we go to my actions, you can see that I'm going from experiment all the way to deployment. And I don't know if that's the right thing for me, right? We might want to take the new model maybe once a week, or we might want to retrain, not just every time we check in code. But maybe we got to make it so that people can actually submit pictures so that the model gets better. And that's what I've been thinking. But that introduces a whole bunch of things, though. Like, I don't know if I want random people putting pictures into my blob storage. It's not that I don't trust y'all. It's that I don't trust y'all. So, yeah. But maybe there's a way we can use cognitive services to filter out inappropriate images. Okay. So let's think about that a little bit. We may need to add a page to do this. So right now we have a page. So let's go back. So the AI is good. Now we got this video component, which is awesome. In theory, we can reuse this video component on another page. And we have a theme. Does this theme even work? I don't know if this theme works. Let's take a look at the index here. How do we do this? So theme. Oh, I see. Welcome to Rochambeau.ai. Let's hold on. Let me open up this website again because I think I have it open here. There we go. Oh, man, every time I go to this page, I get judged by this dude. I'm gonna save this image. There you go. Because I'm gonna save it forever. Because the lighting sucks on this. This camera sucks, by the way. Okay. um yeah, I mean, I might get someone submitting images where we need to blur stuff or not use it. All right, my friends, before we move to the next part, we are at the top of the hour. Welcome to those coming to the AI show. We are going to be looking at multivariate anomaly detection with Louise Han. So make sure you get your questions in there. We'll come back to our project after Louise. But we need to make some decisions of what we're going to do. I'm happy to take your suggestions because we're really here for you. Okay, we're here for you. All right, so let's get this going here. Let's see if we can't get Louise Han to show up. Here we go. This is Louise Han multivariate anomaly detection. It's kind of cool. It's loading up right now. I'm a huge fan of it. I hope you are too. Let's take a look. You're not going to want to miss this episode of the AI show where we talk all about the latest from Azure Multivariate Anomaly Detection with my good friend Louise. Make sure you tune in. Hello and welcome to this episode of the AI show. We're going to talk all about the latest from Azure Multivariate Anomaly Detection with my friend Louise Han. Louise, how you doing, my friend?
Hi, Seth. I'm doing great. And hi, everyone in front of the screen. This is Louise, and I'm the product manager of Anomaly Detector Service. And today, I'm really happy to be here in the AI show to announce the GA of our new feature called Multivariate Anomaly Detection.
That is fantastic. So before we dive in, can you tell us what it is for those that might not know what it is?
Yeah, for sure. So a holistic overview of anomaly detector service is that it's an AI service can help you detect anomalies on your time series data. So the input is really simple. You just give your time series data, and then all the machine learning thing is all handled by anomaly detector service, and the output will be the anomaly detection results within the response. So that's basically the thing, and I will show you a demo here of how it works. Okay,
fantastic. Before I get to that, so let me just see if I understand. If I have data that has a timestamp on it, basically, that has multiple dimensions, if something happens that's out of the ordinary, this service will basically tell me this is out of the ordinary. Am I getting that right?
Exactly the same.
Fantastic. Well, let's go to your screen here.
Perfect. So here you can see there are 5 common sensors from a car. Instead of a car, maybe another equipment or a really complex system, they will have multiple variables. And at that time, you will not have enough time to deep dive into every single variable because there is a lot bit cost and human resource and also the time. So you have to use one model to handle all the variables in your equipment, in your system. So that is multivariate anomaly detection's magic. So here you can see we have these 5 sensors already prepared. And then what we should do is just train a model based on your historical data. After I click this button, it will take several seconds because this is an animation from the demo page. And after that, the model is trained. What you should do right now is to trigger the inference. So the inference is actually the anomaly detector service to help you detect anomalies on your model with your data, with your inference data side. So here you can see the results of all the inference results. So here you can see there are some red bands here. The white red band will show you the anomalies. So if I just click one anomalous timestamp, I can get something like this. So I can first get the severity. So this is a chart of the severity, show you how severe this anomalous is. So for example, if the severity is at a really high number than the others, then at this timestamp you have to take care because probably there will be a disaster happen right after this timestamp. And
that's amazing.
besides
So
that,
if I could pause, we could pause right there because I this is awesome. So if you scroll up, basically what you're saying is that first chart at the top, if you scroll up a little more, those are the sensors coming in. Those
Yeah.
5 sensors. So one is like an optical filter or whatever, a pump pressure or whatever, and you basically click that thing and it found where there might be potential problems. Am I getting this right?
Yes, yes, perfect.
Fantastic. And so the severity of the anomaly is the second chart. The third chart I didn't understand as much. Can you tell me what that one is a little bit more?
Yeah, that's what I want to say right now. So the contributor is something called the contributor rank. So for example, when I click this timestamp, we can get a chart like this. So you can see these are exactly the 5 sensors that I showed in the inference and also the training data site. And the percentage is showing the contributor score for this anomalous timestamp. For example, at this timestamp, we can see the first sensor is optical R filtered. It is having the largest percentage in this contributor rank. So that will mean this sensor contributed the most to this anomalous timestamp. So if you don't have enough time to deep dive into all the sensors, you can just focus on the top 1 or top 2, which are the most anomalous sensors. So that will help you to do the root cause analysis.
That is really cool. So I mean, you obviously you've showed us the easy way to do it. Is there a way, for example, for me to do this, like if I want to integrate it as part of some system or write my own code with it? Is there a way to do that?
Yes, for sure. Because our service is a site of APIs, so you should definitely to use the APIs or the SDK function to try to train and also to trigger the inference for your multivariate anomaly detection work. So here is the demo notebook for the multivariate API, and you can see here are some basic introduction of how we are using this multivariate model and how the process is going. So we separate all the 7 APIs into 3 parts: the training, the inference, and also the list and delete model. So you just use the training model API to trigger a train to create a model, and then you get the model status by this API, whether it is successful or it is failed or is still running. And after you get a ready model, you will trigger an inference. So here we support 2 kinds of inference. The first one is the asynchronous inference API. So with that, you can do some batching or micro batching inference. And with another inference API called the synchronous inference API, you can trigger that like a streaming or a near real time or real time inference. So these are some different options for your preference. Okay, so
This is
these are.
cool. This is really cool. So basically what you did before, it just called these kinds of APIs with this nice this is the back end if you want to make your own kind of back end as well.
Yes,
Cool.
exactly. Yeah, and I will scroll down a little bit to see the codes. So basically the prerequisites is to create an anomaly detector service in the Azure portal, which is really similar to other coding services. So you just create that and copy your key and endpoints and paste it here. And at the same time, because you will use your data to do training and use your data to do inference, and for your security, we don't store your data. So you have to create your storage account to store your data. And the upload and the preparation is really simple. So you just prepare your data in one CSV or in separate CSV files and upload to the storage account, and tada, you will get the blob URL, which is really easy to get in the storage account. And then is the coming to the prepare your data part. So you will specify your data schema and also the blob storage, the blob URL for your data, and then you will go to the key part is the training model. So within training model, we have already set everything for you. What you need to do is just download this distributed notebook and run in your local compute, and to set some training start time or training end time based on your data's preference. And then you just run this part of code, and with few minutes or with few hours, it all depends on your data size. And then you will get the model status by this piece of code. So here you can see the model is ready. Then you can go to the inference part. And the inference, as I just mentioned, we have 2 different types of inference, which is the synchronized one, which is I called batch inference here. And with that, you can trigger a batch inference with this piece of code, and you will trigger that with a result ID for that inference task. and you will get the batch inference results and also the status. So here is the final results of my batch inference. So you can see here we get whether it is an anomaly for this timestamp and the severity and also the score, which is the raw number of this severity. And we will also get more interpretation, which is like just showed for the contributor rank stuff. So this is all the things in a data frame. And also for another different type for streaming inference, it's pretty the same. So you just give the data as a JSON format, and then you will get exactly the same pattern and schema for the streaming inference detection results. So it's here. And also we have two other operational list models and delete model APIs. So you can list your model based on their display name and also based on their status to select whether this model you will delete or you will do some modification on that. So final is the part of the visualization. So you can see here, I just input my raw data for the 5 sensors here, and then I will draft a picture to let you know how complex this question is. It's really hard for me or for, I think, for any people to check whether it is an anomaly or not. So that's why we exactly need this service. So after we apply our service onto that, we can see all the anomalies has already been marked as right. And at the same time, we'll get the score and also get the severity here in this line chart. And the most important is about the contributor rank thing. So you just run the piece of code and you will get at this exact, the specific timestamp, how is the contributor rank looking like. So you will get something like this. And the last thing I would like to highlight here is about the change the variables, because the underlying model is the graph attention network. So we'll learn the correlation between different variables. So for example, if the sensor 1, the series 1, and the series 3, and the series 1 and the series 4 have some really big changes on their correlations, so we'll mark this as a really big anomaly. So that will have the top contributor score. So this is the table that you should look at and should take care and also take action on. So basically, that's all for the multivariate.
That's really cool. And like you literally just shoved all this cool information in my head, because when I looked at the original sample data, it just looked like fuzz. There's no way I would scroll up to the one. It literally
Yes.
looked just like fuzz. And then when you went through the model, it said, "Oh, wait a minute. I know to you, dear human Seth, it looked like fuzz, but there's some anomalies in there that maybe you should take a look at." So that is actually really, really cool. So a couple of questions. Are you finding, like, if I'm thinking about use cases for this, what should I be thinking about? Like, is it any time series data useful in this type of scenario?
So currently for this multivariate, it's better to use some really high frequency instead of just a cycling, maybe minutely or hourly. That would be good, because for the multivariate, we need a lot of data to learn and to train the model. So if you have data like in monthly granularity, it may not be that good. And for monthly, that will most happening in some business metrics. But in really complex system like the car or some X-ray machine or some drilling rig, or there are some production line on the pumps. So that will be perfect thing and perfect equipment to be detecting anomaly on.
That's a great suggestion. So step number 1, make sure you have a lot of data so that it can learn what the patterns are and then show you when those patterns are being violated, so to speak. The second question I have is, can we use that model to predict into the future? So let's just say I get a bunch of 5 new input sensor data on the new timestamp. I can put those in and the model can predict basically the things that are happening in the future as well. Is that right?
Currently, the forecasting is happening under the model instead of just to give you an output of the forecasting thing. So you can understand this multivariate is combining the forecasting and also the anomaly detection together at the same time.
I see. That makes a lot of sense. Well, this is amazing stuff. Where can folks go to find out more?
Yeah, actually, we have a good documentations, and we also have the GitHubs like here, so you can focus on the link that Seth will show, I think, down below the screen,
This
and
one
go
right
to
here,
the
right?
docs. Yes, perfect. Go to the docs, go to the GitHub repos, and also we have a cool Teams channel. You can join the Teams channel. The community will share with you a lot of updates of our products, and also you can feel free to discuss about our products or any machine learning thing.
Well, this has been amazing, Louise. That was a lot of information you put into our heads. This has been delightful. Thank you so much for spending some time with us.
Yeah, thank you so much for having me.
Awesome. Well, my friends, you've been learning all about the latest from Azure Multivariate Anomaly Detection with Louise. Thank you so much for watching, and hopefully we'll see you next time. Take care. How about them apples? Wasn't that cool? Louise is awesome, by the way. She literally so much information. It was delightful. All right, so here's a question from Mark Whiting. Are there other use cases for multivariate analysis other than anomaly detection? Opportunity analysis. Absolutely. I think in this particular case, the multivariate anomaly detector's only job is a model, for detecting anomalies. But multivariate analysis can also detect opportunities, I think. If you are one of those, folks that's like, challenges are more like, or problems are opportunities dressed up in disguise. Everyone had that one teacher that was like, y'all had that teacher, and you are all like,
that's great. Thanks for telling me. I feel so much better.
Right? So maybe that. But yeah, I think so. And I don't know what you mean by opportunity analysis. Like predicting the future, there's tons of that stuff. I mean, there's a whole cottage industry of predicting stock prices, and it doesn't work all the way all the time, but there you go. But that's a great question. Okay, if you have any other questions for Louise, feel free to hit me up. You can always reach me at Seth Juarez on the Twitters. By the way, if I may, let me turn the music off. I don't know, man. There's been a lot of tech layoffs, and the thing happening at Twitter has made me sad. And so if any of you are from Twitter and got laid off, reach out to me. I'm happy to be helpful in whatever way I can. So, yeah, I just watched Doom Scrolled last night, and it was just sad because it's people I respect that I follow on Twitter that were let go, and people that I actually literally know real life. Like I've hung out with them. And so sadness all around. If you are experiencing challenges in the tech industry, if anything, I'm happy to be at least a listening ear. So sorry for the interruption, but saying Twitter's reminded me of the whole situation. Incidentally, I bought a domain name about, how long ago was it? Let's see if I can find it. Hold on, let me see if I can find it. I still have it. And you know how everyone has like hold on. You know how everyone has a like a graveyard of domain names they purchased because they had an idea one time when it was late at night? I have that too. And in one of them, I got to find the year when I purchased this because this is probably, here we go. Two-factor auth. It's fantastic. Oh, hold on. Oh, this is the wrong one. Oh, there we go. Okay, so I'm trying to find it. I'm looking in my domain name graveyard. Here it is. Let me see when I purchased it the first time. I wonder if you can tell. Like, I have it here, but I don't know if I can tell when I purchased it the last time. But it was probably the year 2001. So we're talking like 20 years. I've had this domain name for 20 years. And this was before Facebook, before Twitter. And my brother and I, he's a designer. He's like now VP of like creative at some place. So this is like, we decided that we were going to make a website where you could join, and then other people can become your fans, and then you can talk to each other online. This is like 8 years before Facebook. I still have the domain. I'm looking at it right now, laughing at me. Maybe it's time to dust it off so we can have a place to hang out. Yeah. Yeah, I bought this domain name 20 years ago. It's laughing at me. It's sitting there looking at me, laughing at me. I use Namecheap, by the way. They don't pay me to say that. But yeah, it's just my domain list. Wow, that is a graveyard of broken dreams, isn't it? Oh, these are such good domain names. Oh, so sad. So there you have it. All right, back to our show here. We are going to make a page on our website that will make it so that we can grab some images. So let's do that right now. So let's make a new file, and this is going to be a I don't know. It's naming things is so hard. We're making a page where I can submit images and label them and put them back into the machine learning process, basically. Okay. So what should I call this? I guess I'll call it train.tss. I'll take this index. I'll do that because I'm lazy. We don't need this. Train. You don't need any of this stuff. Boof. Goodbye. 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 And then we'll say training. Training. Okay. So there's a lot going on here. So I'm just going to remove some of this stuff here. So here's the first div. And non-breaking space. Then, oops. Control Z. Nice. Non-breaking space. Then we'll take this little doohickey here. And then we'll do that. We'll thank you, Copilot. There you go. Okay, so it's saying I have a div problem, so you're good. Close here. You're saying you don't have a matched div, so let's see, div here. What's this problem? All right. I'll give you a corresponding closing tag. Nice. Okay. And then that's train. All of this stuff, we'll try it. But if I go now to the page, so let's open this up here. So let's close this here. Let's open this up. And if I go to the localhost 3000, we have this, but now I should have train. Cool. So now we have this thing. So how do we want to format this? I'm thinking design-wise, we'll put the design-wise, we'll put this frame here. This will have the video, and we'll have to have like some radio boxes that say rock, paper, scissors, none. We pick it, and then we hit capture or something. And then over here, we'll just start showing the images. What do you think? Thoughts? Okay, let's do that. Cool beans. So let's go back to this thing right here. I think in this case, we want to use the video. No, not that video. This video. We got to choose the device also. So we've got to do a little bit of what we did here. There's a device selector and then the video itself. So let's do that. Device selector and the video itself. Looks like we have a couple of settings. We might be able to abstract this even more if this is what's happening. Let's go back to the index. Looks like we have some of these things that we need in the training. So let's put that over here. Doot, doot, doot. We don't need this one. Good. I don't think we need this one either. What is this? What is this saying I should put here? Thanks, Copilot. That's unsettling. Unsettling. All right, what do we got here? Let's take a look at the website here. Refresh. And then we pick this. Yeah, so now we got this thing. Cool. So life is proceeding as we would want. Cool beans. So here we're going to have to put the radio buttons and then some fat button here that says capture. Okay, so this is going well. And then the images will show up here. Cool. Okay. And then we'll have like a submit button, right? Okay, cool. So this is working. Oh, why did I do that? That was dumb. Localhost 3000 train. Okay. Oakley dokley. So we're in the train area. We've got the video reference. I did this one time. I'm trying to remember when I did this. But I did it with Vue.js. Let me look over here on my projects. Oh well, we'll figure it out. Okay. I wonder. Oh, let's go back to this page and see what it looks like. I wonder if we just do it below because I'm lazy. Let's just do that. Let's just make it work. So here, we are going to have radio buttons. Is it input type equal radio? Let's try that. Is this even a thing? Do I not even know how to do radio buttons anymore? Oh gosh. Everyone's going to watch me live try to figure out how to do radio buttons HTML. Yeah, this is what happens, okay? I am a senior engineer looking up how to do a radio button. Okay. We got you. The internet has got me. Avi, this is not cool because it needs an end tag. What's your deal, huh? Form elements must have labels. The heck? What does that even mean? Form elements must have labels. Element title has attribute has what? Okay, form element has no placeholder attribute. All right, let's see what that means. Let's see what that means. Okay, how to fix form elements have no label. Oh, good. This is accessibility, so I'm going to solve this problem. Does anyone else know how to fix this? Oh, I see. Got it. Okay, that's cool. I'm all about accessibility, so we're going to do it. Label for... I wonder, though. Is it the ID we need to give it? Is there an ID? Or is it name? No, it's name. So ID. Label for. Let's see what that. I've never used that before. Okay. Label. Oh, hey, look at this. I did not know you could do that. Let's do that. Label. And then we can do this. This we do not need. And then we can say... Still not happy? Oh, it's happy now. It's happy. Very happy. Alrighty. Label. That's cool that it's forcing accessibility like that. I think that's cool. So I'm happy to oblige. So let's go back to our thing, and you can see male, female, wonderful. Okay. So we just need rock, paper, scissors, and none. So we're going to call this gesture. And we're going to put these in spans and maybe put some... Let's put them in spans. Span. Span. Maybe we'll do a for each. So let's get this going. And non-breaking space. Okay, cool. So we have this. And we want to do a span for each one of these. And we're going to say class name. Class name equals px2. I think that will do it. Padding x2. And what we'll do here is we'll do a const gestures equals. Oh, good. How's that for Copilot? Thank you, sir. And then we'll just do a gestures and look at that. Ka-doop. You're a genius. You are a genius. I think that's right. No. I think it's like this. Oh. Is that right? What's wrong with this? Let's do a JavaScript list map. Yeah, I know. A JavaScript list map JSX. This is what a senior engineer does. Isn't this amazing? Why is my internet so slow today? Here we go. Oh, cool. We'll do that. If not is empty, gesture. We'll just do gesture. Gestures, I think, is what we have. Gestures. And we'll do gestures dot map a G. And then we'll do this. By the way, I'm still of the opinion that G. Is empty. What? It doesn't like this? Cannot find. We'll do this. Because this is truthy if it's not empty or exists. Very good. All right. Let's go to this little doohickey. Ka-doop. Look at that. Hey, yo. Doot, 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 doot. Patty, it's good having you, my friend. Signing off. We'll see you hopefully soon. Take care, my friend. All right. So it looks like we have a little bit of an issue. Doot, doot, doot. And we'll put boxes around the span, and we'll we'll padding the Y a little bit too. So let's do that. Too many here. PY2. Oh, nope. PY2. Nice. Inspect. Oh, each child in the list should have a unique key group. Ugh. Just a key prop. Okay. There it is. Key. So we'll do key equals G. There you go. No more problems. Okay. So then we select the webcam. You can pick the rock, paper, scissors, or none. Nice. I think the in Western cultures this goes to the left. So we'll do that. There you go. Boop. And then we'll put a little space there. How about we do boom, boom, plus. There you go. Rock, paper, scissors, none. Nice. And then we'll have a nice button that says capture. This is the worst button I have ever seen in my life. This is the worst lunch I have ever had. Class name equals margin X. Okay, cool. I don't know if that's enough. Let's do a 6. Oh, I wanted margin Y. That's why. Okay. All right, that's the button. Maybe we can steal the button beauty from this other thing. So here's the button. Let's do this. No. Okay. Let's take a look at. Yes. 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 Cool. And then when we hit capture, it'll just start putting images in here with their labels. Cool. So what we'll need is we will need a list. But how do I do this in a React kind of way? Let's think about this. I am thinking I should make a component out of just this video thing, because that I could have literally just brought it over, but I had to bring a bunch of other stuff in there. That wasn't cool. Because the device selector and was all this together was really cool. Okay. So now I need to have the actual images. I wonder what the best way to add elements. Add elements. Okay. Add elements to array in React. Let's see how there's probably like a super crazy way to do this, because yeah. Really? Oh. This is interesting. I'm not against it. Okay. Yeah, I know. Hold on. Yeah, I got it. Images, and then set images, and then this is going to be. Let me create an interface here so that it looks the right shape. Interface scores. Interface image, and this is going to be a image. It's gonna be a string. We'll do images as base 64, and then label also a string. Okay, and then we can get rid of that. Okay, and then what we can say is use state. No, we should do image. No, we should change this, because there's too many images everywhere. You see what I'm saying? Can't do that. Interface training image. Okay. Cool. We'll use state here. Would be a training image array, like so. Boop. Nice. So what we can do is, when the image starts with nothing, anytime we add an image, we'll add it to this thing. So we'll call this on click equals add image. And then we'll do a const add image equals. We'll just do the event handler here. I don't know what type it is, and then we'll do this. All right, let's remind ourselves how we did handle things. Handle submits. Looks like I emptied them. Console.log evd. Yes. Is it still mad? All right, let's see what this does. So this is all there together. Let's see if it's unhappy to the point where it won't compile. Okay, looks like it's not unhappy to the point where it won't compile. And then when I hit capture, you can see there's a synthetic base event. The thing about it is we don't need to know anything about the button, so that's why I think I could take this out. And what we could do is we could say, up there, look at that. Look at that. That's amazing. Wait, are you seeing this? Copilot suggested the code that I need to use. It's literally that. Hold on. I'm going to go back. Yes. That. I had too many curly braces, but that is exactly what I want. And the image label will come from. Let's just we'll get the value from gesture. Because look at this. Set images sets the image to this, and the image is the frame that I got, which is the string. And then the label is none. But in this case, we need to pull the gesture from this. So let's see how React deals with React radio button group. How do we do that? Tell us, oh internet, how to do this. Give us your tips. Yeah. Checked is true on. I got to do checked is true on one of them. Whoa, that's a lot of data. Yes. Get initial state. Selected option is option 1. Okay. I know. I mean, sorry, I say I know because I'm reading it. Yeah, it selected literally the exact code that I wanted. It was amazing. It's not like just copying code and from anywhere. It's literally, it's pretty cool. Okay, got it. So what we're doing is we're going to have a const current label, and then we have a set current label, and we're going to select none. And then what we're going to do is we're going to say checked equals, and then we're going to say b equals select a current label. Let's see if that works. Yeah, so now it's none, which is exactly what we want. Oh, what's going on? Yeah, I know. We'll do the on-change soon. Cool. Okay. And then what we're going to do is we're going to, first of all, format document. Then we're going to say on change equals e set.current label dot value. Boom. Okay. Cool. E dot target dot value. Cool. Let's try it. So that's cool. Let's. And then when I hit capture, well, now I can't see anything. When I hit capture, I want to get label equals current label. Cool. Now what we're going to do is we're going to print out all of the images. Okay, so let's see what that looks like. So we're over here. Now we're cooking with gas. Let's just do something lazy and quick. Div. And then what we're going to do is we're going to do this kind of thing. We're going to do this kind of thing, but with divs. So let's not do that. So this is not going to be gestures. It's going to be images. Images. And then it's going to be images.map. And we'll take this out. I think we're doing a span, but I mean, I guess it's okay. Let's do a div. And then div. And then we'll do an image. And the key is going to be G. Ooh. I don't know if we have a key. So key's going to be, I guess it's going to be the image. Although that image is not a good one to use. Ooh. Okay, and then we'll just say image. Source, g.image. What is this? What's our problem here with this? And then we'll say alt equals g.label. And then we'll put a span here with the g.label. Okay. I know this is ugly. Let's see if this will fix our... Oh, there we go. There's none. Let's do a scissors here. Nice. Paper. Nice. Rock. Cool. Nice. So it looks like we've got some stuff going on here that's doing the kind of the right thing. The idea is that we want to submit these, but the thing is that this image is too big. It's too big. Is there a way to resize the image so that it's a little smaller? Let's see. Let's inspect this image here. Inspect. I wonder what the size is. Inspect. So it's 341. I wonder if I change the width to like 100. Let's try that. Width equals. I wonder if it'll make it smaller for me so that I don't have to do anything. There you go. Hey, yo. Look it, we're doing a thing. Now, if there was a way, let's do, looks like I have to hit capture every time. Paper, no. Now I got to find a way to delete it if I don't want it. Like if I click on it, it just goes away. By the way, this is cool, right? We're making a thing using React, which is amazing. By the way, if you're watching, this is to train a Rochambeau model, because it's the model I trained using 300 images that are quite old. But it would be nice. It would be nice if I could just continue to add more images, retrain. If people wanted to log on and do their own images, they could. So this would be the most absolute best Rochambeau model in the entire universe. but we need to give it a key. So let's give it a key here. Let's give it a key. So we'll give it a key. So we'll do key, and then we'll make this a number. Okay. And what we'll do is I wonder how we can remove an item from a. I guess the key will be the current index. So let's do this. Key equals, comma, and it's going to be images.length. Let's see if this works. So this would be the key, g.key, label. Okay, let's see if this does it, if it puts the right key. So there's no key yet because I didn't do that before, so they don't have it. So let's do this, and let's just put some nuns in there. Nice. That's cool. So that is indeed the key. What we'll do is if we click on this, we've got to be able to remove a particular element. Oh, look at the time. Oh, it's time. So it's a great question. Why am I not using a timestamp for the key? It's because I want to be able to remove that object from the array. I want to be able to remove it from the array. So when I set the array to remove it, I have to set the array minus that element. So how to remove specific index from Java. Here we go. It's splice. Cool. Okay. So what we're going to do is when we unclick this image, onclick equals remove image, and we'll pass in the index. The index will be g.key. Okay, cool. So we'll do remove. We'll do const remove image key number, and what we'll do is we'll say set images. Whoa! Look at that. I don't know if I like a filter. I like the splice better. So splice, we'll start at the, because I think we saw the splice here. Car index 1. So we'll do key, and we'll only remove 1. Okay. Cool. So why is this not happy? Okay. Yeah, this is weird. Mouse event handler. This we want the key. What? On click. How do we pass? On click, remove. Oh yeah, see, because this is a pointer to a function. Oh, we'll do this. Done. Hoo-ah. Let's see if it works. We'll refresh this thing. We'll do this. We'll do a rock here. Capture, 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 capture. And if we click on it, it should go away. Oh. Something is wrong. That's okay. We will fix it next time, my wonderful friends. It's been a delightful couple of hours to spend with you all. Thank you so much for spending some time with us. This has been another episode of the AI Show Live. We did two things today. We did Azure ML Registries and we did Multivariate Anomaly Detection. We worked on our Rochambeau project and generally had a good time. Thank you so much for spending some time with us, and hopefully we'll see you next time. Take care, my friends.